Have you ever heard that whiskey weighs less than water? Today we're going to confirm it right here at our virtual bar. Now imagine this captivating experiment setup. We start with 2 shot glasses, sparkling clean and resting on a sleek bar. One glass is filled with whiskey, the golden potion from the Highlands, its slow-motion pour from a vintage bottle mesmerizing. The other glass gets filled with water, the life-sustaining element cascading from a crystal-clear stream. Then the plot thickens. A playing card is placed over the whiskey-filled glass, covering it entirely. With a hand steady as a rock, the whiskey glass is flipped upside the card holding the liquid at bay and placed directly on top of the water shot glass. Now comes the suspense. The card is slowly slid from between the 2 glasses, but not entirely, leaving a tiny gap for the magic to unfold. Behold, a close-up, slow-motion observation of the 2 liquids switching places, the dance of the whiskey and water. But what causes this? It's all about density, a principle of science which we will explain. Density is the substance's mass divided by its volume, or simply, how much matter is packed into a certain space. Whiskey and water may look identical, but they have markedly different densities. Water is denser or heavier than whiskey. When allowed to mix, the denser water descends and the lighter whiskey ascends, resulting in the whiskey-water switch. This experiment isn't merely an entertaining party trick, but an engaging way to illustrate a core physics principle. It's a reminder that science is not limited to labs, it's everywhere, even in unexpected places like a bar. So, the next time you find yourself at a bar, dazzle your friends with this clever trick that makes science tangible. Just remember, always conduct your experiments responsibly. And there you have it, a whiskey-water swap, all thanks to science. Here's to a final triumphant observation of the whiskey-water swap. Imagine a scene from a time long before electricity. We open with a stock image of a bustling ancient marketplace, then transition to a still shot of a dimly lit vintage home. The only illumination comes from a humble lamp, simple yet functional. Its source of fuel? Not electricity, not batteries. We pan to a stock video of a bottle of olive oil, the golden liquid glinting in the soft light. Yes, this lamp is fueled by good old olive oil, a beacon of light that has weathered the epochs. Cut to stock footage of a hand crafting such a lamp, a clear glass filled 1/4 with olive oil, a piece of string long enough to reach the bottom of the glass and protrude from the top. This string is our wick. Cue a sequence of images depicting the science behind it all. The olive oil acting as fuel, melting near the lit string. The liquid is drawn up the string, a process known as capillary action, beautifully depicted by a shot of a tree drawing up water or a paper towel absorbing a spill. We see the oil reaching the flame, combusting into heat, light, and a hint of smoke. Stock video and photos illustrate the transformation of oil into gas, and its reaction with oxygen to create fire. The string is a conduit, guiding the oil from the reservoir to the flame. This simple, effective system has illuminated our world for millennia, and we illustrate it with a montage of stock footage spanning centuries. As we close, we see the final product in action, casting its warm glow. The humble olive oil lamp, a testament to the elegance of simplicity. And as the narrator speaks the final line, we overlay text that reads, "Isn't it what a little bit of oil and string can do? That's the power of science." Witness something extraordinary, a balloon that doesn't burst even when pierced. Ready to be astounded? Now let's unravel the enigma of the balloon kebab. Picture this, a vibrant balloon, inflated to perfection, a skewer, and some dish soap. On this journey, the initial step involves smearing a generous amount of dish soap on the skewer, mitigating friction as the skewer navigates through the balloon. Next, visualize slowly inserting the skewer into the bulkiest parts of the balloon, typically near the tied end or at the base. These segments harbor more latex, making them more resistant to bursting. Gradually force the skewer through while feeling a mild resistance, which is absolutely normal. Persist until the skewer emerges from the other end. You might now be pondering, why doesn't the balloon burst? The secret lies within the mesmerizing science of elasticity. Balloons constructed from latex possess extraordinary elasticity, bestowing upon them the ability to stretch considerably before rupturing. When the skewer is inserted through the denser parts of the balloon, the latex stretches and makes room for the skewer without bursting. But the dish soap is not to be discounted. Serving as a lubricant, it allows the skewer to glide through the latex without inducing excessive friction, which could lead to a tear and consequent popping of the balloon. With the dish soap, the skewer navigates smoothly, upholding the integrity of the balloon. This intriguing experiment brilliantly illustrates elasticity and surface tension, highlighting how much a material can stretch and conform without rupturing. The principle extends beyond balloons to other materials such as rubber bands, dough, and even human skin. The final picture, a balloon kebab. Who could have thought science could be so thrilling? Ever witnessed the peculiar dance of raisins? No? Allow us to this spectacle. Picture it like this. You found yourself at a bar, leisurely enjoying your soda, when an idea strikes you. Why not conduct a mini science experiment? With a casual reach into your pocket, you bring out a petite handful of raisins and nonchalantly drop them into your vibrant drink. The ensuing show is one of effervescent enchantment. But first, let's delve into the science behind this spectacle. The magic is all due to two main factors, buoyancy and carbon dioxide. Buoyancy, the force that permits objects to float in a fluid like water or air, is responsible for keeping ships afloat or balloons in the air. The raisins, having a density greater than the soda, sink to the bottom of the glass initially. This is where carbon dioxide, the second element of our act, comes in. The soda is teeming with tiny carbonated bubbles. When the raisins are dropped into the drink, these bubbles latch onto the wrinkles and crevices of the raisin's surface. As the number of attached bubbles increases, the raisin becomes less dense than the soda. Consequently, the raisin ascends to the surface. Upon reaching the surface, the bubbles burst, and the raisin, now denser than the soda, descends back. This rhythmic cycle of rise and fall makes it appear as though the raisins are performing an enticing dance in your drink. The next time you're at a bar, wow your friends with this seemingly simple but truly fascinating science experiment. All you need is a glass soda and a palmful of raisins. While it's a delight to watch the raisins perform, comprehending the science behind it adds an extra layer of thrill. The duo of buoyancy and carbon dioxide transform an everyday glass of soda into a mesmerizing, bubbly dance stage. And that's the secret to making raisins dance. Don't forget, science is all around us, even in your drink. Well, that was quite a journey, wasn't it? We plunged headfirst into the fascinating world of science with channel Exploring the Science. We kicked things off with the whiskey-water swap, a delightful demonstration using the principle of density for a spectacular visual effect right there on your screen. Remember, whiskey is lighter than water, so as we flipped the glasses, the denser water ascended into the whiskey glass while the whiskey descended into the water glass. It's a great icebreaker, right? Next, we set the stage alight with the olive oil lamp, a simple yet impressive DIY lamp made with olive oil and a wick. The science here, the wick absorbs the oil, and when it's lit, the flame vaporizes the oil, generating a fuel to keep the flame alive. The illumination was truly a sight to behold. Our next stop was the eye-catching balloon kebab. Don't be fooled, it's not magic, it's polymers in action. Balloons made of these long, flexible molecules seal around the skewer when inserted through less stretched parts, preventing the air from escaping. A visually stunning experiment that wowed everyone. And lastly, we brought you the charming dancing raisins. The soda bubbles clung to the rough raisins, causing them to bob to the surface. Once there, the bubbles burst and the raisins sank back down, creating a delightful dance. This experiment offered a fun and easy demonstration of buoyancy. I encourage you all to replay these experiments on our channel, Exploring the Science. Remember, science is all around us, not just in labs. So stay curious, keep your eyes open, and continue your journey with us, exploring the fascinating world of science. Remember, the world is full of wonder and is one of the best ways to uncover it. Until our next video, keep experimenting with Exploring the Science.